Okay, this is a short FRQ 2021 of AP Physics 1 is based on rotation. It says that there is a cylinder of mass m naught that is placed at the top, and the length of the incline is L naught, height is h naught, and then after reaching the bottom, it also slides or rolls without slipping on the floor as well. So they are interested to know that on this grid, if we sketch the graph that represents the total kinetic energy, remember they're asking total, not kinetic, I'm sorry, not translational, not rotational, but the sum of both, total kinetic, as a function of the distance traveled by the cylinder as it rolls down the incline and continues to roll across the horizontal floor. Right, so we know that there are three kinds of energies involved, right? One is the gravitational potential, which is mgh. One and the other, in a way, it's only two. One is the potential, which is this, and one is the kinetic, which is translational kinetic energy and rotational kinetic energy. And we know that the mechanical energy is conserved, right? Although I know there is a friction because there is no slipping, but friction doesn't do any work in the case of pure rolling, right? We know that, we should know that. So can I say that now potential and kinetic are basically getting converted into each other? We start from a maximum potential, which is mgh naught, and we drop down to a zero potential, right? Now let's find out how this change is happening. So at any point, let's say the mgh, we know that mgh naught is the, or mgh at any point is the potential energy, right? And we have to find in terms of L. L is this distance, right? So that's fine. We can find the relationship between h and L. So let's say this is h, this is the h at any point, and let's say this is theta at any point, which is obviously so not at any point. This is the theta of the incline, and let's say this distance is something that it has traveled. Let's say this is L, and obviously this will be L naught minus L, right? So if I say that what is sine theta, sine theta will be opposite, which is h, over hypotenuse, which is L naught minus L. So if I cross multiply, then L naught minus L multiplied with sine theta is going to be small h. And this small h I'm going to plug in over here. So the potential energy is going to look like m is constant, which is m naught, g is constant, and then this will become L naught minus L sine theta. Remember that theta is also constant. So from here, I can clearly see that potential energy is a linear function of the length L traveled along the plane, and it is of negative slope as well, because you can clearly see that it was maximum here and then zero here. So if it is decreasing linearly, potential is decreasing like this, so obviously the kinetic should increase in the same fashion because the sum is always conserved. So the total kinetic energy is going to look something like this. It's a straight line and it go all the way till this point, and the maximum total kinetic energy will be m naught gh naught, which is basically same as the maximum potential energy. And after this, the potential energy is not changing, right? It's just zero because the height is not changing. And if the height is not changing and the potential energy is zero, it means that the total kinetic energy has to be, constant because there is no conversion. Remember, friction is acting, but it's not doing any work because this is pure rolling case. So whatever it value it has achieved, it's going to remain constant throughout. So I'm just going to draw a horizontal line after it reaches the bottom or on the floor. Right, I hope this makes sense. The next one talks about this cylinder is again placed at the top of the incline, and a block of mass m naught, which is the same mass, of course, as the cylinder, is also placed at the top of a rough incline, right? So rough incline means this has friction. Now, when the cylinder and the block are released at the same instant, the cylinder begins to roll without slipping while the block begins to accelerate uniformly. And the cylinder and the block reach the bottom of their respective inclines with the same translational speed. So they're asking in terms of energy, you need to explain that why this happens. All right. Now remember, there is no rotational kinetic energy in case of a block, right? So what we can, and there is a rotational kinetic energy in case of a cylinder, of course. So what we can say is they both start with the same initial potential energy, right? So let's talk about, well, ball or the cylinder first. Let's talk about cylinder. So initial energy is just potential energy, which is m naught gh naught. And finally, it got converted into translational kinetic energy and rotational kinetic energy at the bottom, right? Can we agree on that? Because we just did the same thing, right? Honestly. Okay. Um, for the block, for the block, it also starts with the same initial potential energy, m naught gh naught. It also ends up with the translational energy, kinetic energy, but there is a work done by the friction, right? There is a work done by the friction because in this case, friction is doing work. In case of pure rolling, friction doesn't do work, but in case of block, as in translational motion, friction does work. In fact, it will make more sense if I just put this work done by the friction on the left side, because as per the conservation of total energy, initial energy plus work done by the conservative force, non-conservative force, which is friction, is going to be equal to translational energy. I'm rating same KT because they are saying it has the same translational speed and mass is already same, so it's going to be the same kinetic translation energy. So minus work done by the friction. This is the equation for this one. This is the equation for this one. Remember that if we find work done by the friction is going to come out as negative because friction is acting here and the displacement is in this direction. So the work done by friction will be negative and this double negative value will come out to be positive, right? So now we can see that, see, this is same, this is same. So obviously the left side is same, and if the translational kinetic energy is supposed to be same, it means that actually the rotational kinetic energy, the energy that is converted into rotational energy in case of a cylinder, is basically equal to the absolute value of the work done by the friction. So that's in case of a block. So that's why initially they started with total energy. In case of cylinder, some got converted into in the rotational energy, and in the block, some was taken away in the form of work done by the friction, and hence they end up with the same translational